Hello viewers, welcome to Ada. In this question, we are asked why is Zener highly doped? Okay, so let us start with the explanation. So, at first, we need to know what is a Zener. So, Zener, this is basically a PN junction device. This symbol look like this. So, the Zener diode, this is a special type of diode which is designed to operate in the reverse bias region and maintain a constant voltage across its terminals. Okay, so this is particularly a PN junction device. Now we know PN junction operates in forward bias mode and in the reverse bias mode. So the Zener diode, this is specifically designed to operate in the reverse bias mode because it functions as a voltage regulator. So now the thing is, why the Zener diode is highly doped? The first reason will be low breakdown voltage. So what is low breakdown voltage? The Zener diode is heavily doped to specifically have this low breakdown voltage. Now this breakdown voltage, this is the particular voltage value at which the diode starts conducting in the reverse bias region. So as we know, in the PN junction, when the diode is forward bias, the depletion region decreases. So the electrons from the N side will move on to the P side and the holes from the P side will move on to the N side, for which current will flow within the diode. But during the reverse bias region, the depletion width increases. And for that reason, during the reverse bias, we do not get any amount of current. Because if we see the curve of PN junction diode, it is somewhat like this. Okay, this is the forward bias case. So as we can see, as the forward bias voltage is increasing, the current is gradually increasing. But as the reverse bias is increasing, the current is very much minimum. Okay, so this is the characteristics of PN junction. But in the Zener diode region, the breakdown voltage is that particular voltage at which the diode is conducting in a reverse bias. So the Zener diode characteristics is like this. First, it will have a normal characteristic like PN junction. Then after decreasing the reverse bias voltage up to a certain amount of value, after this point, the diode starts conducting. Okay, so the characteristics will look like this. And this particular voltage point, this is known as breakdown voltage. Okay, so why do we need Zener diode highly doped to maintain a low breakdown voltage? And why do we need a low breakdown voltage? A low breakdown voltage allows the Zener diode to start conducting at a lower voltage, make it is more suitable for the voltage regulation application. For example, here the value is almost minus 5 volt. Okay, so if the Zener diode was not highly doped, okay, I am assuming the Zener diode is lightly doped. So this breakdown voltage, this will go up to from minus 5 volt up to suppose minus 20 volt. So attaining this much reverse bias voltage is not easy. Rather than that, we are more comfortable with minus 5 volt. So to attain a low breakdown voltage value, we will be highly doping the Zener diode, which helps the Zener diode to maintain a constant voltage across its terminals when it is operated in the reverse bias region. Okay. So basically what the Zener diode does is, suppose this is a AC supply. Okay. This is a resistance. This is the Zener diode which is connected. Okay. And there is another resistance, load resistance, which is connected across it. So I am assuming that this is a variable AC supply, which gives us from 0 to 12 volt. Okay. So what does the Zener diode operates in this circuit? Suppose this Zener diode has a voltage of breakdown voltage of 5 volt. I am not considering the polarity here. So this is a variable AC input power supply. It will give us values from 0 volt up to 12 volt. So the thing is, if the value is less than 5 volt, suppose we are applying 4 volt power supply here, at the output we will be getting 4 volt power supply. But the thing is, as soon as the value increases this breakdown voltage value, for example, if I am applying 10 volt supply at this input, even then it will regulate the voltage. It will give us 5 volt at the output, which means as long as the value is less than 5 volt, which is less than the breakdown voltage. So we can say as long as the input power supply value is less than the breakdown voltage, we will be getting that input power supply value at the output. But as soon as the input power supply value exceeds the breakdown voltage, the Zener diode will regulate the voltage. And what does it do? For example, here this is 10 volt. So this will exceed the breakdown voltage. So it will give us only 5 volt at the output. Even if we apply 11 volt or 12 volt, it will give us only 5 volt at the output. So even if we increase the power supply or the voltage supply at the input, the output will remain the same. So it maintains the voltage regulation. Okay, so this is one reason. Another reason is the avalanche breakdown. Okay, so heavily doping the Zener diode increases its ability to withstand high reverse voltages without experiencing any catastrophic failure. Okay. So what does why does this avalanche breakdown occurs? So as I have said, when the Zener diode is highly doped, it has the ability to withstand high reverse value voltage, or we can say we can increase the reverse bias of the Zener diode easily, which we couldn't do in the PN junction, because if we increase the value of the PN junction reverse bias, then after attaining a certain amount of value, the diode will break, or it will enter the breakdown region, and after that, the current will be flowing uncontrollably, or we can say we cannot control the current flowing to the diode. But in Zener diode, increasing its doping will increase its withstanding capability, the higher reverse bias voltages. For example, suppose in the PN junction, after a value of minus 5 volt, the current will gradually increase. Okay, current will gradually increase, and we cannot control this particular value of current. It will increases exponentially. But in the Zener diode, we are highly doping it, so it will have the ability to withstand high value of the reverse bias voltage. For example, minus 5 volt, minus 6 volt, minus 7 volt, like this. Okay, so this will have a particular effect on the avalanche breakdown. So this avalanche breakdown, this effect particularly occurs when the reverse bias voltage exceeds the breakdown voltage of the Zener diode. As I have drawn here, this is the avalanche breakdown. So this is the breakdown voltage. As soon as the voltage value or the reverse bias value exceeds this breakdown voltage, the current is gradually increasing. Okay, the slope becomes more steeper. So in this breakdown region, the Zener diode conducts heavily and can handle a large amount of current while maintaining a relatively constant voltage drop. Okay, so this is the main function of our Zener diode. Okay, this is the main function of the Zener diode. So due to this reason, we will be highly doping the Zener diode, because our main function of the Zener diode is to use it as a voltage regulator. But the thing is, if we don't dope it highly, what happens is the breakdown voltage, the value of the breakdown voltage will be high, which is, as I have said here, which will be hard to attain. And even after attaining the breakdown voltage, the amount of the current will increase considerably. So it will enter into the breakdown region, which is the avalanche breakdown region. So during that time, the current will flow uncontrollably. But as it function as a voltage regulator, it should give constant voltage at the output. So for this following reason, we will be doping Zener diode highly, okay, to maintain a low breakdown voltage and to control the avalanche breakdown while working as a voltage regulator. I hope this is all clear to all. Thank you.